Hello, I would like to solve problem number 7 in this video. So this is about partitioning linked list. We have a linked list like this. This is unsorted linked list. So we're gonna partition this linked list based on a reference value. So for example, in this video, in this problem, we're gonna take our reference number as 3. So after running the program, our output should be something looks like 0, 1, 2, 3, 5, 7, 6. So this is how it should look like. All the numbers which are less than 3 should come before, and all the numbers which are greater than 3 should come after 3. So I'm gonna write a function by thinking I already have a existing linked list. I'm not using any fancy related stuff, just some basic math functionality. I will have a function called define partitioning. What I need, the inputs are like I need a head pointer, and also I need a reference value, which is let's take this as x. So what I need, I need two variables. One will be like the beginning of the linked list, and one is ending of the linked list. So I will be taking one is end equal to. So initially I will initiate to start. I will initiate to start of the linked list. So this one is head, and I will also take another variable which will also point to head. So what I'm gonna do is like if I do any, I'm gonna just traverse the list. While traversing, if the element is greater than 3, I'm gonna append to right side of the linked list. If it is less than 3, I'm gonna append it to before 3. So I have two variables ready. I'm gonna traverse this, while I'll take this one as a this logic should apply to starting from the linked list. So this variable I will be using it later, while current is not equal to none. What I'm gonna do is like I will just make next equal to current dot next, and this is where we use our logic. If current dot data is less than x, so if the element is less than x, what we're gonna do is we just make we just insert a node at the head. We do current dot next equal to head, and we make head equal to current. But that is not the case, and if the number is greater than x element, the reference element, which in our case it is number 3, we're gonna make so we'll just append that to the end of the linked list. So we're gonna make end dot next equal to current first, and then we just make a tail equal to current. We just make end equal to current, and then after this condition we just make current equal to next. And also we have to make so our endpoint should have null at the end of the linked list. So this one should point to null pointer. So we're gonna do this is end equal end dot next equal to, we just make a none because this is the end of the linked list. And yeah, we just make return head. So if you take this one as an example, okay, so if you take this one as an example, it will just go through this linked list, and it will just go through this loop first because it is less than 3. So it's gonna be the first element in the list, and then it goes to the second element. It will check 5, so it is greater than 3, so it's gonna 3 after 5, so it will be the last element in the list. And then we go to the 7. The 7 comes here. 7 is greater than 7, so we make 7 equal to the type. So this is how it will pass through, and at the end we just make return end dot next equal to none, because the last pointer should pointing to none value, so we just make that in the end. So this is how this partitioning we can partition the linked list. This one shouldn't take much time complexity in worst case also, because we're just looping through only one iteration. So this is a time complexity, and we're not using any extra space, so it should be constant space complexity.